Welcome back guys, this is Shrikant. Today we are going to talk about 3NF. Last video we talked about 2NF. So to make a table in 3NF there are certain rules. Those rules are as follow. The first rule says it should be in a 2NF. Okay, fine. So those are new one. Please watch my earlier video related with the 2NF. You will get a lot of idea on how to make a table in 2NF. Second rule says there should not be any transitive functional dependency. What does that mean? It means that there should not be functional dependency and which is transitive. So there should not be transitive functional dependency between the values or between the column. What does that mean? For example, let's say I have three value A, B, C. And my requirement is I want to make direct relationship between the A and C. But if I see the structure or the data, I don't see direct relationship between A and C, right? But if I want to make a relationship between A and C, I need to go through what? I need to go through B. So basically, this is called as the transitive dependency. If I want to find out the relation between A and C, I need to go through B, right? Because I need to visit B to get value of a C for A, right? This is called as a transitive functional dependency. I'm giving you the real-time example with the column. I would say, let's say I am having a three column: column 1, column 2, and column 3. In this one, the column 1, I would say it's a key column. Column 2 is non-key column. Column 3 is non-key column. And by looking at the data, by understanding the structure, I would get a conclusion that in this table the column 1 is the key column. So these two non-key columns should depend on the first column. That is fine. But when I try to understand the data, I see one thing importantly there. This column 3 does not make any sense to have direct relationship with the column 1. Column 3 is depend on a column 2. There is a direct relationship, right? So I would say this is called as a transitive dependency. This is a generalized example. I'm giving you real practical example now. For example, I am going to consider the example which we have discussed for our normalization. So this is a data and this is the example which I have. What exactly this data says? This data says I have a first column called as a student number. I have another example called as a student, column student name. I have another column called as courses, and I'm adding some more columns here. For example, zip. Okay, then I'm going to add state here, or and a country. It's optional, but I'm trying to make more. So let's say I'm having zip 1. Try to understand it. I'm going to show you when you have a raw data from that raw structure how you can design the 3NF structure from the scratch. So it will require your patience. So let's say state is Maharashtra MH and the country is India. Sam is located in zip 2. State is AP and the country is India. So this is a raw data I do have with me, and someone asked me, can you normalize this data? Can you make a normalized version of this data, right? So okay, I will go from 1 to 3. First, to make a table in a 3NF, it needs to be in second NF, and to make a table in a second NF, first I need to make in a first NF. So what will I do? I will do one thing here. I will simply convert this data into the first NF. How would I do that? Please try to focus. This is quite interesting and lengthy, but it's very helpful for you. So if you focus this video, your all doubt related with the normalization will be clear. As per the definition of the first normalization, these are the four different rules. So unique column should be there in the table, then the order of the column should not matter, right? The single value attribute, then the attribute domain should not change. Those need a detailed explanation related with the first NF. Please watch my earlier video, you will get idea about that. So right now what exactly I am going to do? I am going to convert data into first NF. So what are the different rules? Rule says all the column should be unique. So I'm just copying all the columns. Next is all the values should be single valued. Then I am going to make single values there. As I already have data, so I'm just trying to copy paste. So this is the data we have. Just paste it down. Then we have a zip. We can write zip 1. Here. Then we have 1 zip, right? For SAM, zip is 2. State is MH. We are trying to make data in a first NF. Then country is India. Then AP. Okay. So the data we have like this, right? This table is in the first now. Why? Because all the column names are unique. That's fine. All the values are atomic, single value, and the domain name should not be changed. The domain should not be changed means the data type. I feel that integer, string, integer, string, right? So all the rules of the first normalization are satisfied. So this version of the table is in the first normalized form, right? Next, we are going to convert this, but looking but looking at this data, I am thinking that this data is actually um, redundant, right? I can see 1 Shrikant C sharp, 1 Shrikant, 1 Shrikant. So image like this. Oh, okay, this is redundant. So I need to convert this table into 2NF. How I do that? So to make a table in a 2NF, then it needs to follow all the certain rules of the first NF. So first of all, table should be the in the first NF. Then second thing is that there should not be partial dependency. So what exactly we will do? We will we will uh, we will split the data and we'll make a separate table actually. So as we discussed in the last video, what we'll do here, we'll make a student information in separate table here. Likewise, student number, because in a second normalization, as I said, we need to split it a redundant data and to make a table, unique table if needed. So I think we need to split the data to make a table, right? So student name, I would say 1 Shrikant. Only I feel only there are only 2 students actually. So I am just trying to add 2 entry here, Shrikant. Then another entry is for Sam. Okay, now fine. Now I realize I made it. then I'm going to, this is, I am saying student master table. Okay, now this is the first table I created by looking at this data. This, I feel basically it's a redundant one. Now I'm just trying to make another table by linking with the main table. I could say these are the data I have, and just adding column here student underscore id and linking them back. Student underscore id, and we have 4 entry for that, 11112. So you can simply select this like, and just paste it here. Then we join this data with this, basically these are the two tables, and just take out the data which are leftover columns actually, because we are trying to remove the partial dependency actually. So I created one student master, another just table I'm joining this student id with C#, right? So this is my data. By looking at this data, I would say this table is in the second NF. Why? Because as per the definition of 2NF, the first, the it should be in a first NF, or both this table looks like this is in a first NF, right? All the columns are different, all the values are single. So this is in first NF, and the definition, as per the definition of the second NF, the second thing says what exactly it says? It says there should not be any partial dependency on a composite key. So if I want to make a unique relation in this table, how would I do that? I would say one course C#. Okay, I can use this key basically as a composite key, one C#, right? One sp.net, and this could be my primary key for this table. And I think table is in the second NF now, right? Because I splitted the data, that's fine, third rule says, and yeah, looks good. This is this data basically in a second NF. Now I personally feel that this data again having some redundancy. Redundancy of what? Redundancy in the sense like zip code, state. See, if I see carefully 1 mh, and this data is repeated actually. This is a redundant data, and I think this data need to be again in a again need normalization. So I will go for 3NF. What exactly I will do with this now? Now I have only this data with me. So in this case, as per the definition, as I said, to make a relation in 3NF, what exactly it should be? To make a relation, first of all, it should be in a 2NF, right? Okay, now this table is in 2NF because there is no functional or basically there should not be any partial dependency. I'm not seeing any partial dependency here because zip don't need to worry about the courses and student. So there is no, actually this is not depend on any of those, so there is no partial dependency. And let's make this table into 3NF. How we can do that now? To make a table in a 3NF, there should not be any transitive functional dependency. Now by looking at this data, see, this data is in the third normal form. If I want to make a primary key on this table, I would select these two columns, one and the student name and the course, right? I could say this one. But if I'll come here, I'll see one important thing here. See, country and the state. Country and the state depend on the zip, right? So basically this every column, every non-key column should be depend on a primary key. This is as per the definition. But sometimes what happens, sometimes there should not be a directly dependency, and to derive that column, we need to go through some intermediate one. So in this case example, this is the best example actually. See, student and courses, this is a one kind of information, and another information is zip, and I want to make a direct relationship between the student ID and the country. So to make a relationship of the student ID and the country, I need to first have a student ID, then I need to have zip, then I can reach to country, right? I can't directly get a country for the student ID. To get a country, I need to go through zip. So in this one, the example which I explained you, this is my column 1, this is my primary key, and zip is my column 2. Zip is my column 2 to relate with that, and country is my column 3. If I want to make a direct relationship between the column 1 and column 3, I need to go to the relation with the help of column 2. See, hope this is clear. So by looking at the structure, I would say this table or this data is having a transitive dependency, because if I want to find out the country, I need to go through zip, and the country is depend on a state, and state basically depend on a zip. Likewise, you can say country is depend on a zip and zip is depend on the student ID. Perfectly fine. So still there is a possibility that we can normalize this data. How to do that? In that case, we can say we can create another table for this. So far we have only two tables. This is the student information table, we call as student master. Now we need to tune this table again. So how would do that? We need to normalize 1 to the 3 NF. I'm going to create another table, country information or zip information. I would say zip master, and the date. And I'm looking at the data. I could say there are only 2 entries. So just add a column, straight country. Zip is 1, country is MH, sorry, state is MH, country is India. Zip is 2, state is AP, country is India. So this is my zip master. So now what will I do? I will join this two table, student ID data with the zip, simply. I would say this column name I am going to give is as a zip. Just try to understand. By watching this video 3-4 times, you will get a lot of idea. So I'm just replacing ID 1. This belongs to 1. This belongs to 1, and this belongs to 2. Just try to understand. I converted this 2NF data, this column data, like this. I converted structure like this. So this is the one table, this is another table, and there is one more table we just created in 2NF. What was that? It was the student master. So technically we created 3 tables. The first table name is student master. So interviewer asked me, can you normalize this data? I would say yes, why not? So this is the first table I created, called as the student name, student master. Another table I created is called as the zip master. Right? Okay. This is second table. and the third table I created by joining basically the student ID and the zip. I could again say like this. This is for simply because order of the column doesn't matter. So I join student ID, I join zip, and I got the courses information. So if I want all detail of the student, how could I get that? I just need to simply join with the student master table, and this only I could say the student zip info. This is the third table. So this is the three table. This is the third table actually we created. So I could say I have all the information. If I just append the student information with this, I need to join with the student master. If I need to append the zip information, which country he belongs, which state he belongs, and the what exactly the zip number, so I can just join with the zip master. I will get all the zip information, and this is the information basically which need to be present for every record. So by looking at this data, if you see and see, this is the simple data, and I just given you. And by looking at this data, if someone asks you, can you normalize this data, or can you create a structure in such a way that it needs to be a normalized one? Yes, I just did it, right? This is the raw data we had, then we converted it into the first normal form, then all the rule applied, then we converted that data into the 2NF, all the rule of the first NF applied, then the second and the second rule, like no partial dependency, that's fine. I created those version there. Then again I realized that there is a data redundancy. So what exactly I did, I again went to the 3NF, and the rule for that 3NF is it should be in 2NF, that's fine. Then there should not be any functional transitive dependency. Transitive dependency we already said, if non-prime key column is not totally depend on the primary key column, then that's a problem, and non-key column is dependent on another non-key column, that is called as the transitive dependency. Okay, what's the definition? Non-key column is dependent on another non-key column, right? So what exactly we did, we separated that redundant data into another table, let's say zip one. So zip master we created student master, and then finally we joined it back. So by looking at this three table, I would say this is the normalized version of my data. See how difficult it is? No, it's not difficult. It is, everything is depend on your understanding. How do you play with your data? How do you understand your data? Everything is depend on that. So this is the real-time example I have given you, because when I was studying engineering and when I was studying the database management system, trust me, I was not sure really it works like this, because when I was studying it, everyone was taking the different example for explaining the first normalization, second normalization, and third normalization. I was bit aware of the definition, but I was not sure practically how to create the best version from those tables. Now I think this video will help you, and if I try to create table, yeah, I can create the table. Just imagine this is your organization structure, and you want to store the data in a more normalized way. Using this design, you can have a lot of data, and you have the less chances of anomalies, and less chances of redundancy, right? Hope you guys understood the 3NF. If you are having doubt related with the first NF, 2NF, 3NF or normalization, please ask me your question over the comment section, and please let me know if you have any doubt. If you like our video, please don't forget to share and subscribe our channel. It will help us and motivate us. If you still don't like our video, please don't hesitate to comment over the comment section. We'll appreciate that. We'll try to improve ourselves, and thanks for watching. Have a great day.